Morning to all. I am Ms. Sudha, Assistant Professor in Physics, Department of Science and Humanities. I am from Sri Muthukumaran Institute of Technology, Chennai. This session, I am going to explain about the topic of properties of matters such as elasticity, stress and strain. Unit 1. This is properties of matter. This is for first year students in first semester. So this is properties of matter in Unit 1. Here elasticity, Hooke's law, stress strain diagram and its uses, and Poisson ratio factors affecting elastic models and tensile strengths. These are all I am going to cover in this unit. First, elasticity. So what does elasticity means? So nothing but the materials can regain their original shape from the deformed force. For example, for the rubber band and saucer ball. And then inelastic material. Inelastic material means it does not regain its original shape or size even after the removal of the applied force. Example for that, bread and paper clip. Then stress. Stress is nothing but it's defined as deforming force affecting per unit area. Its unit of stress is force per area. Its unit is Pascal, and Pascal in another word we can say as Newton per meter square. Types of strength. There are two types in which one is normal stress and another one is tangential stress. Normal stress means force is applied perpendicular to the surface. Tangential stress means force is applied along the surface. Here this diagram shows according to the force applied to the material is affected in this way. Here two kinds of force acting and perpendicular to the material means the material will compress. At the same time, two forces acting in opposite with each other means the material will get the tension, like that the three diagram shows. And then strain. Strain means changes of dimension from their original dimension. We can say as a formula for strain is strain equal to changes in dimension to original dimension. It has no unit. Types of strain. There are three types in which one is longitudinal strain and another one is shearing strain and then volume strain. If it is longitudinal stress means here when we apply the force to the material, the changes will occur in the lengthwise. Like that, if you apply the force to the material, the changes if it is occur in the angular means that is called shearing strains. Like that, when you are going to apply the force to the material, the changes will occur in the volume means that is called a volume changes, volume strain. And then we are going to see Hooke's law. Hooke's law says that stress is always directly proportional to strain. That means this is applicable only within the elastic limit only the stress is directly proportional to strain. Here to cancel the proportionality constants we need to add the constant that is E. Stress is equal to E into strain. To find out the E value then E equal to stress by strain. E is a elasticity. Here having the unit is Newton per meter square. It was invented by Robert Hooke. That is why this name was given. Types of modulus of the elasticity. There are three types of modulus we have. One is Young's modulus and rigidity modulus and bulk modulus. Young's modulus means for wire, rod and bars there is a longitudinal stress force per area that produces changes in length per unit length. In such a cases, stress is equal to force per area, strain is equal to del L by L. Here longitudinal modulus means the ratio of the longitudinal stress to longitudinal strain. That is denoted as a formula Y equal to force per area by del L by L. F. So after changing this formula, getting the formula final is FL by A del L. Then rigidity modulus. Rigidity modulus means a shearing stress alter only the shape of the body, leaving the volume unchanged. For example, consider equal and opposite shearing force F acting on the Q below. Shearing stress is defined as the ratio of the relative displacement between two layers in the direction of the stress to the distance measured perpendicular to the layers. When you're going to say this bulk material, so you can see clearly when we apply the force to the bulk material, here having the angle has been changed from Q to Q dash. That is called a shearing stress. The shearing stress here denoted as a symbol is pi. Then strain equal to pi equal to d by L. Bulk modulus. Bulk modulus is the ratio of the volume stress to volume strain is called a bulk modulus. Here bulk modulus is denoted as a symbol is here K equal to volume stress by volume strain. Volume stress is formula force per area by volume strain is denoted as a formula del V by V. After changing this formula, K equal to PV by del V. Here F by A, that means force per area is generally pressure P, we may write. Okay. Properties of the moduli of the elasticity. Here all solids have three moduli of the elasticity and fluids like gases and liquids have only bulk module of the elasticity. That means bulk materials only have affected by in the three ways. And second, by the Young's modulus and bulk modulus of the materials undergo changes in size or volume due to the applied force and there is no change in shape of the materials. So according to bulk modulus, here when we apply the force to the material, only the changes will occur in the size and volume. That is why it's called a Young's modulus. And then third one is by the rigidity modulus, the material undergoes changes in shape only due to the applied force and there is no change in size and volume of the material. Here stress strain diagram. Let us consider a body which is subjected to the uniformly increasing stress. Due to the application of the stress, the changes in dimension of the body takes place. The stress is developed. If we plot a graph between stress and strain, we get the curve like that. Here some of the points we have in this graph. One is the A, which is the point is called proportional limit, and elastic limit, this is yielding point. So here what they are coming to say means when we apply the pressure to the material starts to increase the proportional limit. So here O to A, it's denoted as a proportional limit. Here only presenting a points only will act to the Hooke's law. Hooke's law means what you know very well. Strain is directly proportional. Stress is directly proportional to strain. So that means when you increase the stress, according to the strain will increases. So that is why here presenting particle will react to the Hooke's law. After the point A to B. So A to B, this limit we are saying as elastic limit. And then B to C, this point is lower yielding point. C to D, this is, so D is a breaking stress. If you exceed the stress beyond the lower point, the materials will goes to bending nature. Bending nature means it will break. Uses of stress and strain diagram. So by knowing this stress strain diagram, students they can able to understand the material's nature, like ductile nature, whether the materials are ductile or brittle or plastic. Factor affecting the elasticity. So what are the factor affecting the elasticity means? First one is temperature and stress and annealing. These are the factor affecting the elasticity. A material is subjected, when the material is subjected to the large number of cyclic of the stress, it loses its elastic property even within the elastic limit. Temperature. So when you increase the temperature, the elasticity nature will be affected. That means the elastic property of the lead increases when the temperature decreases. So these materials alone, when the temperature decreases, it has the large number of elastic property. Second one, the carbon filament becomes plastic at a higher temperature. Effect of annealing. If annealing is made to material, it results in the formation of the large crystal grains, which ultimately reduce the elastic properties of the material. Thank you.